Photomultiplier is a photoelectric radiation measuring instrument that transforms light signals into electric ones. The device is a vessel placed into a vacuum bulb. It has a glass or quartz window. Through the window, light travels to a photosensitive element or photocathode. The photocathode emits electrons. Then the electrons multiply in specialized electrodes called dynodes. At the end of a dynode circuit, there is an anode or a collecting electrode. The current running through the anode is proportional to the photocurrent generated by the photocathode. The characteristics of a photomultiplier mostly depend on the structure of the photocathode. They include such parameters as spectral sensitivity, quantum efficiency, and dark current, also known as noise. The thickness of the photocathode is an important parameter. The thicker the photocathode is, the greater number of photons absorbed and the smaller the number of electrons that need to be emitted. The thinner the photoemitter layer, the greater the number of photons that will go through without being absorbed. The electrons running through a photocathode are accelerated by the dynode circuit. The latter can consist of 14 elements. Focusing electrodes are often used. They direct all the photoelectrons coming from the photocathode to the first dynode. When a photoelectron reaches the first dynode, it triggers a second electron emission. Thus it increases its factor. All the electrons are accelerated in one circuit, running from one element to another. The multiplying factor depends on the voltage between the dynodes and on the total number of dynodes. The number of electrons may be multiplied by several millions, if 12 to 14 dynode levels are used. A channel electron multiplier is a device based on continuous dynodes with distributed resistance. A channel electron multiplier is a tube made of glass with high lead content. It can also be made of ceramics. The tube is often bent and has a photocathode situated inside, behind the taking lens. Photoelectrons emitted by the photocathode go through the narrow and bent semiconductor channel. When voltage of several kilovolts is applied to a tube, electrostatic field appears inside. Under the influence of this field, the electrons inside the channel are accelerated. As they interact with the walls, they cause secondary electron emission. The number of secondary electron multiplication cycles and the total amplifier ratio of the channel electron multiplier depend on the length and inner diameter of the tube. Among the advantages of the channel electron multiplier are its low level of dark current and wide dynamic range. Photomultipliers are mostly used in optical instrument engineering, spectrometry, television, and laser technology.